Okay, section 4.5 is about isosceles and equilateral triangles. So I put up here just so you can see an isosceles triangle. Isosceles means that I have two congruent sides. So you're going to see here where I have those tick marks. Wherever you have two congruent sides, the angle opposite of that is going to be congruent to the other angle, and those are called my base angles. So these two that are congruent can be considered my legs. This side here is considered the base, and then the angles that are congruent to each other are my base angles. The angle that's by itself not congruent to anything is called the vertex angle. It's very important for you to understand the base angles because the next theorem is going to show you that the base angles of an isosceles triangle are always congruent. So that's what theorem 4.3 is saying. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So that means if I have this side congruent to here, the opposite angle would be going diagonal, so angle B would be congruent to angle A. The converse is also true of that theorem. It says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if I know my base angles are congruent, then I also know that this has to be isosceles and these sides have to be congruent. Okay, so using those theorems, it's going to ask you some questions about sides or angles being congruent. So letter A, is AB congruent to CB? So AB is here and CB is over there. Well, notice you have two base angles here in the, oops, let me scoot it over a little bit. Here in the corners. So those are my base angles of the big triangle. So yes, those would have to show that the sides opposite of them would also be congruent. So I would say yes, and then I would say by the converse of the isosceles triangle theorem. Next one, is angle A congruent to angle DEA? And again, I would say yes, because my sides are congruent, so therefore the opposite angles will also be congruent. So I would say yes, and I would give the theorem by isosceles triangle theorem. Now if you're not sure which one you're using, make sure you look at the conclusion. So in this conclusion, I'm trying to come up with the fact that the angles are congruent. That's how I knew I would be using that for letter B. Okay? But on letter A, I was trying to show my sides are congruent, and that was the conclusion piece, so that's how I knew I was using the converse. So make sure that you're checking that conclusion and it's matching the answer you're looking for. Okay, next piece here. On yours, you should have a theorem 4.5. I had to write it in there so it looks a little bit different. But in theorem 4.5 it says if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So you want to make sure you know what that's saying. So if this is my isosceles triangle and my vertex angle is at the top, so I have a line that bisects that angle, that means that these two are now congruent to each other. A perpendicular bisector means this is going to form 90 degrees, and then also these two pieces, these smaller segments, are now congruent to each other. So let's see what that looks like when we're asked for a problem. So this is asking me to find the value of x. And you see that I've already done some marks on there. This line is showing what theorem 4.5 is trying to describe. It's a line that is bisecting my vertex angle, because this is an isosceles triangle. And then it's being perpendicular, so it's going to also bisect these sides. Now the sides don't really matter in this case because of the fact that I'm trying to find an angle measurement. And what I know is that one of my base angles over here is 54 degrees. So if this is an isosceles triangle, I also know that that angle is the same over here. So angle C is also 54 degrees. Like we already said, this line will end up being a perpendicular bisector, which means that this angle will end up being 90 degrees. So I could find the letter x by setting up an equation if you wanted to. where you're going to either, oh, sorry, I got confused. I end up showing you how to find x and y, but I was just showing x here. You would add 90 plus 54 plus x and then set it equal to 180, and then combine your like terms and subtract it from 180 to get 36. In the example, it was missing what letter y is, and letter y is the vertex angle up at the top. So you could find x and then just double it if you wanted to, because you know that y is both of those together. Or I set up an equation where I was using the big triangle and I added 54 plus 54 plus y and then found that it was equal to 72. So it's up to you which way you wanted to approach it. I probably would approach it this way because it's a little bit easier to understand, but there's a lot of steps to it involving that perpendicular bisector from Theorem 4.5. Alright, last piece here, talking about equilateral triangles. Corollary to Theorem 4.3 says, if a triangle is equilateral, then the triangle is equiangular. So make sure you know what those words mean. Equilateral, lateral stands for sides, equa means equal. So equilateral means they all have the same sides, they're all congruent to each other. And equiangular would mean that all the angles are congruent. It can be in reverse and it's still true. So if I have a triangle that is equiangular, then I also know that it is equilateral. Here's something else to note. If I'm an equilateral triangle, think to yourself, what are all the angle measurements in there? I hope you are taking 180 and just dividing it by 3 because each angle is the same amount. So this is something to write down because if I'm equilateral, I know the angle measurement every time. Every angle will be 60 degrees in an equilateral triangle. So that's just something to make sure that you're aware of. Okay, let's take a look at this last problem. It says, what are the measurements of A, B, and ADC in the photo at the right? Well, angle A, if I use just this small triangle here on the left, I see that it's equilateral. And we just got done discussing that if this is equilateral, then I know every angle in that equilateral triangle is going to be 60. So angle A has to be equal to 60. The same thing could be said for angle B, because angle B, if I look at this triangle that's just on the right, it's also an equilateral triangle, so every angle inside of there is also 60. So I know angle B is 60. Then it's asking for angle ADC. Well, angle ADC, I know that angle ADE is 60. That would be this top angle that I'm writing. And then this angle right next to it would also be 60 because it's another equilateral triangle next to it. So if I just added those two together, I would find angle ADC, which would be 120. Okay, so this lesson is about isosceles triangles and equilateral. So isosceles means I have two sides congruent, and then also my base angles would be congruent. And then I also have equilateral, equiangular triangles, and if it's equilateral, I automatically know every angle in it is going to be 60 degrees.